All right, so today we are talking about limits, and we will have a little bit extra time that I normally have for this class, talking about limits, because we introduced it yesterday. The advantage here is that we're going to be able to look at some practice problems, and that's really kind of what I like. We solved limit problems numerically, we solved them graphically. If you look at your notes, that particular function that we had, you don't need to write this down. This is just kind of getting your brain warmed up here. That was f of x equals x cubed minus 1 over x minus 1. We found the function value at several other points. For instance, f of 0 was 1. F of 2 was at 7. Y'all remember that, however, there was something weird going on at 1. What was the function value at 1? Does not exist. But we said, that's true, it doesn't exist. There is a hole in my graph. And the reason why there is a hole in the graph was because when you plug in 1 into the function rule here, you end up with a 1 in the denominator. And anytime we have a 1 in the denominator, that expression does not exist, okay? Because there's no way for us to meaningfully divide by 0. So I say 1 in the denominator? 0 in the denominator. There's no way, like, dividing something by 0 doesn't make sense to us like in the real world. I can't say, you've got 10 things, divide them into 0 piles, right? You can't put them into 0 piles. It's already at least one big pile. And any way you distribute it, there's going to be a pile, right? So dividing it by 0 is meaningless in the real world. And math is about turning the real world into symbols and then doing some cool stuff with it. However, we were able to say, as we're getting closer on the x-axis to 1, those y values are getting closer and closer to what value? 3 in this case, that's right. And so mathematicians came up with a way of noting that. They would say the limit, I'll just use f of x here, of f of x as x approaches 1 was 3. So I wrote these really kind of close and next to each other so you can tell the difference. The function value at 1, the y value, doesn't exist. But the limit does exist, and the limit is 3. Okay? So, seeing some head nods, it should be good, you should be feeling good, stuff like that. Now, let me kind of throw you a little bit of a curveball. What about the limit at x equals 0? As the x values are getting closer and closer to 0, what is the function getting closer and closer to? When I say the function, I mean what are the y values getting closer and closer to? 1. He says 1. Do you all agree? Look at it right here. As the x values, so as I'm going along this way along the graph, so that would correspond to, this dot, 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 this dot. Look where they're getting closer to this way. This way they're getting closer to 1. If I go march along in this direction from right to left, what are those y values getting closer and closer to? Kirsten? 1. Yes. So I can say something like the limit of f of x as x as x approaches 0 is 1. Okay? And you're like, okay, it's really not that special of a point. It's actually defined, but that's nice. It's nice that what the function is getting closer to is also where it ends up. All right, sort of like you look at somebody and be like, man, look at their life. I can tell what's going on. They are just heading down this path, and it is going to just end up in a train wreck. All right, and then at some point, it's an actual train wreck. Okay? In this case, oh, look at that function. It really is, we're getting closer to 0. It really looks like it's heading to 1. Yeah, it looks like it from both sides. From my side of this of the conversation too, it does from what I see of that person. All right, and then boom, we're like, oh yeah, I knew it at graduation. Yep, it's a 1. Right. Well, no, this person's actually kind of continuous. That right there. There's no goal. There's no gap right there. There's no hole. It's just sort of like this would be someone who's like maybe they're going to be successful. I can tell from here, like, oh yeah, you've seen them at home. They're very successful and resourceful and organized. And then, yeah, they actually are resourceful and organized and are successful. Anyway.
No plot twist.
What's that?
No plot twist whatsoever.
I know, exactly. No jumps or gaps, nothing weird. Okay. What about 2? All right, so we could say the limit of f of x as x approaches 2 is the function, or I should ask this question. What is the function approaching as we're getting closer and closer to 2 here? From the left, what is it approaching here? Sarah? What are the y values approaching?
2.
Oh, no, the x values are down here. So when I say, I'm talking about the up-down values.
7.
You are correct. Yeah, they're approaching 7. What about if I'm coming this way, which means I'm walking down the line this way, getting closer and closer, 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 closer. Same person, Sarah? What are the y values approaching? 7. So they're both approaching the same thing. And guess what? The function is also 7 at that point, okay? Yesterday my point that I was trying to make was that those 2 things are asking different questions. This is asking, what's the function value at 2? This is asking, what are we approaching? What is the y value approaching as x approaches 2? And in this particular answer, in this particular case, at this spot on that function, they both approach it approaches 7 and it is 7. At the spot where there was the hole, it approaches 3, but at that spot it didn't exist. Okay? So just making sure we've got some terminology here. Something else that you'll see this on the homework is sometimes you'll see what is the limit of f of x as x approaches, we'll say 2, and then they'll put a little plus symbol right there, okay? And what that means is from the right. Okay? So that means going at it from this side. So the plus, as a general rule, plus is on the right and minus is on the left. So if we're approaching it from the plus, then that means, from here to here, well, it's approaching 7. But if it was, and then, in this case, the limit of f of x as x approaches 2 from the left, we saw was also 7. Right? But let's pick an interesting problem from your homework that is okay, that's kind of a weird one. Number 3. I'll try to do some of the odds in class. That way I leave the evens for you. Okay. Number 3 has it's kind of weird. What we've got here is if we were to zoom in on that symbol right there. Maybe I shouldn't do this one. It's a weird graph, and let me pick something a little more straightforward here. Aha. Number 13. So this says the limit of f of x as x approaches -2. Well, that's no good because it doesn't have a from the left and from the right. That's okay. We'll adjust it a little bit for our own purposes here. So off to the side, we'll write the limit as x approaches -2 from the left. Okay? So let's look at this. So from the left means, or the minus means from the left. So let's start picking some points here. And Mitzi, I want you to call out the y value of the function to me. What's the y value right here? Yeah, number 13.
Number 13.
So at what?
Oh,
what's the y value?
0.
Yeah. What about here? What's the y value?
0.
What's the y value?
0.
What's the y value here? So I'm going to approach -2. Y value right here?
-2 and 0.
So yeah, I'm not at -2, but as I'm getting really close to -2, what's the y value? It's still 0. You all see what I'm saying? That it's 0, it's 0, it's 0, it's 0. So what is the function approaching? What is it getting closer to as we're getting as the x value is getting close to -2?
0.
0. Okay? Good. On the other hand, what is the limit of the function as x approaches -2 from the right? So from the plus means we're walking this way. Look at those y values. 6, 4, 2, 0. What does it look like the y values are approaching on this one, Kirsten?
The y values are approaching -2.
You are correct. Y values are approaching -2. So this particular function, if we were to relate it to a person, at school, as we're getting closer to graduation, this person's pretty straightforward and everything's normal, okay? Looks real calm. But at home, oh no, they're going down,
Stressing.
right? Okay? So you can see that we're approaching two different things, okay? So now you might be like, okay, Mr. Guy, that's great. You're approaching a different number from the left and from the right. So what's the answer though to number 13 then, okay? What are we, because this doesn't have a plus or a minus on either one of those, okay? And the answer there is, the limit does not exist. This right here, this limit, does not exist. Because when you say what is the limit of f of x that approaches -2, you're asking, what's it approaching from, what number are you approaching from both sides? And the answer is, it's not approaching the same number from both sides. From the left, it's approaching 0, and from the right, it's approaching -2. Those are two different numbers, so therefore the limit does not exist.
Okay, 2 different numbers.
Because it's two different numbers, okay? So that actually is one of our 3 situations in which the limit doesn't exist. I'll say the 3 cases where the limit does not exist. Case number 1, the function behavior differs from left and right. So like I said, on that one, you would just say, does not exist. Let's pick another one. Don't I have some one-sided limits on here somewhere? Wow, all the one-sided limits are really annoying. Sure, let's do number 1. So this one's, I guess, not too bad. It says, what is the limit of f of x as x approaches negative 2? And the minus means what, Sarah? From the left. Okay? So, that means the ants go marching one by one, hurrah, hurrah. What, Sarah, is the y value that we're approaching as the x values are approaching negative 2? Always the y. So the limit is always asking what is the y value. They're going to tell you right here what the x values are. Like as the x values are getting closer and closer to negative 2, what are the y values approaching?
1.
Say it a little bit louder.
1.
1. That's right. So the limit of f of x as x approaches negative 2 from the left equals 1. That's it. That's what that problem is asking. They're literally asking where are the y values going, and the answer is 1. Don't make these questions more difficult than it seems. Okay? Every single one in this homework is asking you where's it trending. That's and if you want to put a little big note to yourself at the top, what are the y's trending? Okay? Because it's always asking what is the limit when we're asking what are the in order for you to meaningfully ask what are the y's trending to, you have to ask me, well, which y's are you talking about? You're talking about the y's over here, you're talking about the y's over here. And I'm going to tell you, oh, what about the y's over around this x value? Okay? So I'm always going to be giving you the x values where I want you to look, and then you tell me what's trending. Sorry, I just kind of like saying that because it makes me feel like we're talking, I don't know, socials or something. All right. Number 3, I guess we might as well deal with number 3. It's kind of weird. It's a step function. I'm going to kind of show you. So that's what these little indications mean. The little bars with little things underneath. What that means is, if we were to look at this, it means there's a full-fledged circle right there, and then there's the graph is horizontal for a little bit, and then there's an open circle. So it's sort of like a stair step. It's like but there's nothing vertically connecting these. So what that means is that right here at like 3.5 or whatever, or 2, 3. It's like 3.5. There's a dot, and it goes, and then full circle. But for whatever reason, I picked this one where they're all super close to each other. Okay. So what I might do right down here is I might zoom in on that part right there. So it looks like at the 0. So here's 1. Right, here's negative 1. Here's positive 1. And that's negative 2, so that's negative 1. So we've got a filled in circle right there, going like that, and then we've got a filled in circle right here. Something kind of like that. So this says, what is the limit of the function as x approaches 0 from the left? So as we're approaching 0 from the left, Mitzi, I'm going to go back to you. What's the y value here? Y value here? Y value here? Y value here? Yeah. So what does it look like? So from the left, what does it look like those y values are approaching? You are correct. The limit of f of x as x approaches 0 from the left. Yeah, it's 0.
Oh, wait, so isn't it automatically 0 if the limit is approaching 0? No?
Possible. Okay, so isn't it? I mean, isn't it automatically zero if the limit is approaching zero? When you say it, you mean the limit of f of x approaches zero from the left?
Yeah.
I mean, yeah, I mean, if it's approaching zero from the left, then it is approaching zero from the left automatically.
It's zero.
Yeah. But I'm gonna, add on to this, just a little side bonus problem for us to get a full and total understanding of these weird types of questions in case I throw one at you on the quiz. What if I were to say, what is the limit of f of x as x approaches zero from the right? Robert? 1. Because this y value right here is 1. If you look at it, as x approaches 0 from the right, we're looking at, so we're going this way, this dot, this dot, this dot, this dot, this dot, this dot. The y values are 1, 1, 1, 1, 1, 1, 1, 1, 1. It's always 1. So that would be, so we're going this way, y value of 1, y value of 1, y value of 1, y value of 1, y value of 1. Alright? It also, it just so happens that we also hit 1, okay? Like we actually are that is to say, f of 0 is in fact 1. But we are also approaching it.
Wait, so like, how do you know which one's like to look at?
How do you know to know from the
like
left?
from the right, because like if the negative, it's like, if it's from the left, it's the bottom one, and from the top, it's 1, right? And one
Mhm.
above it, like how did you figure?
Because the function, I'm gonna try to explain it like, the question is, where's the graph? When I'm talking about x values of -1 and this over here, the graph is right there. Like, these values are all x values of 2, 3, 4, 5, 6. These values over here are x values of -3, -4, -5, -6, okay? So when I say approaching 0 from the left, then that means I need, so here's 0. So from the left means I'm coming at it this way, and so that means this is where the graph is.
Yeah.
I don't know if there's any other way that I could put it.
It's like if you like did the vertical line test, I guess, and wherever that line is touching as you approach the zero
Okay,
from
okay.
the left.
Oh, okay,
Yeah.
yeah.
I don't know.
But yeah, okay.
We'll keep doing some more.
No, because like think about it like this, like you're moving it like this,
Yeah.
and once it hits like 0, I guess.
Is it 1 because,
From the right.
let me redraw that over here, and let me see what I'm.
Oh my gosh.
This is asking the tough question.
I'm like, how do you like you know, because sometimes I'm like, I think it's this.
I don't know. I just got more confused.
Right, okay.
I didn't, it's just like.
Alright, so here is, so way over here, that's -1, and way over here, that's +1. So the question is asked was, alright, f of x equal,
Oh, no, okay, I got myself back. I understand.
the limit as x approaches 0 from the left. And your question is, how do I know to look here or here? Is that,
Like, cause I know for like the left is cause you hit the thingy, but like for the right, you know what I mean?
okay,
That's
so
fine.
we'll do Robert's explanation. I think that's kind of, okay, so you want me to do this
Yeah,
problem?
yeah,
right?
yeah, yeah.
Okay, alright, so Robert says, do the vertical line test, okay? So, we'll get a really big vertical line, okay? So, from the plus means start over here on the right, okay? And let's look and see what y values we're hitting, okay? Alright, what y value am I hitting right now? I'm hitting right on this particular spot on the graph, which that's a y value of 1. I'll make that real obvious. That's
Oh,
Oh, I see
Okay.
the question.
yeah.
so. I'm at 1. Okay. What about now? What's the y value that I'm hitting?
1.
What about now? What's the y value that I'm hitting?
1.
What about now? What's the y value I'm hitting?
1.
Okay. I'm hitting y value of 1. If I were to make a table, okay, if I said f, so at 0.5, it's 1. At 0.1, the y value is 1. At 0.01, the y value is 1. At 0.001, the y value is 1. At 0.0001, y value is 1. So what's the trend here? It seems like it's approaching 1. I still don't know if that's answering your question. You're still a little confused, right?
No, the thing is like, okay, so is it the first?
Come on up here. Come on up here.
Wait, do y'all get it? Cause like if y'all get it,
I feel like the
No.
more we keep talking about it, the more confused
Yeah,
I'm
'cause I
getting.
got it when you said like that, and then I started
Well, I got
thinking
it.
of something else, and then
Yeah, there's like, we kept thinking
I was
of
like,
it.
wait, but what if it goes to
Yeah.
and I was like,
No, that's good.
So like right here, like how do you like? Cause it's approaching 0 like this. Is that how you know?
Yep, yep.
Wait, so but what about like? So when if you're doing it
It's
like this?
helpful for
Oh,
classmates.
wait, why not? Why not? Cause it's not approaching 0. Oh, okay. Never
that
mind.
was approaching
Once you
one,
like
right?
get
Because
close to it.
these guys up here, this is
Yeah.
approaching 1/2. This is
Yeah,
Not
that's-
like
and
touching
this
the
is
y
approaching
axis.
0.
No,
Oh.
that's okay. You just gotta come up here and.
Yeah, I'm
Okay.
like, what the?
Now, my mistake for keeping you back at your table. Kirsten, you had a question.
No.
Do y'all get it?
Yeah, I get it.
Okay.
No, I
So
get it
it's
now.
always, it's never from a side, it's always vertical.
Well,
Exactly. It's
yeah.
always, we're looking at the x values
Okay, that.
as the x values.
Oh, okay,
Cause I thought since it was going this way, I thought it meant like that.
Oh, I should say, yeah, the diagonal. Okay, no, that's good. I'll tell you right now, learning calculus is gonna make sure that you understand what is going on with the graph. Like, you're gonna be like, I never realized that the x value you plug in and it tells you the y value for the function. Like, you're gonna figure that out real quick. So there's stuff that you may have thought you understood, with functions and pictures and stuff like that. You're gonna get it here. Let me, give you the two other situations, and I'll draw a picture for you as well, in which a function, in which a limit does not exist, okay? Then we'll have some more time for examples, okay? The second situation where a limit doesn't exist is what we call unbounded behavior.
Best number of it.
Oh my gosh.
Wait, so yeah, cause they don't meet, right?
That's right. So, the limit as x approaches 3 of f of x. So, it's literally this. If it goes up to infinity or goes down to negative infinity, then, I would say, what y values are we approaching? Well, they're approaching infinity. They're getting higher and higher and higher. And the limit is asking, what number are we approaching? Well, infinity is not a number, okay? It's a concept. So we would say here, does not exist. Now, later on this week, we will actually write infinity. But that's okay, but I'm not gonna write that right now. Right now, I just wanted you to realize that the limit does not exist right there because the function exhibits unbounded behavior right there.
Isn't it also like number 1 because it's different for both sides? Kind of? No?
Possibly. Oh, yeah, kind of, yeah, sort of. You mean, when you say number 1, you mean like this number 1? Yeah, I mean, you could, but the reality is it's approaching infinity this way and it's approaching infinity this way. So you might say, so if I were to be like really technical and ask you this sort of question, which I never will, I'll be like, which of these 3 situations was the cause of this not existing? It might be a little confusing because you might be like, well, the behavior differs from left to right, or if one of them goes to positive infinity, this one goes to negative infinity. but you can just say unbounded behavior. The third case is super rare, and I don't even know if there's any homework problem that deals with it. Maybe there might be one, and that is oscillating behavior. And believe it or not, there are some functions, you probably saw this in your notes, which I need to check, but I'll check those tomorrow, that do something like this. They start to go back and forth, but their frequency gets higher the closer you get to a certain point.
Like rubber shoes.
Okay? And so actually, as we zoom in, it just becomes a thicker forest. And we zoom in, it just becomes even thicker. And it's like crazy, because the frequency increases to infinity. And so we never actually know, does it hit here, or does it hit down there, or does it hit in the middle? I don't, you know? So, so oscillating behavior. So in this particular case, if I were to ask you, what is the limit of that function as x approaches 0, you would say it doesn't exist, because we actually can't trace it all the way through. I don't know if there's any homework problems.
Oscillating.
Oscillating behavior. Yeah, there really isn't. But it's fun to kind of see what that looks like on Desmos. I want to say,
Oh.
no, not sin x over x. Sine of 1 over x? Yeah, there you go. Oh, it's not too big, not too bad of a deal. Let's zoom in.
Until you zoom in.
Yeah.
Oh my gosh.
Oh my gosh, it's like a
It's like a bridge.
Yeah, like we're going
Golden
something, you
Gate.
know? Like a brush.
Avoiding something.
Zooming in, going yeah, you don't ever really see what that is.
Those movies where they somehow end up running into like a random room
Okay,
and yeah, out of nowhere. That's kind of sad.
all right. I'm gonna draw a hand-drawn example because I
Oh no.
never mind how we get a graph like this. Let's just say we do get a graph. So here's 1, there's 2. This is what our graph looks like. Whole actual dot. So this graph is, if this graph were a person, then this person pretty much the same at home, same at school, but then this one time they just did they did something dumb. Okay? Or they did something amazing. Oh, this is a little bit lower, so they did something really dumb. One time mistake, all right? All other evidence in their life points towards they are a 1. Okay? They're 100%.
Was 0.
But at this particular point, they were a 0. All right? Don't judge a book by its cover.
Next day, 0 to hero.
So the limit of f of x as x approaches 2 from the left. So approach it from the left. 1, 1, 1, 1. It's a 1, right? The limit of f of x as x approaches 2 from the right. At school, what does this person look like? What is their behavior? What does this look like they're trending towards? Kirsten?
1.
Also a 1. How, and so, we would say, since they're trending on both sides, what is the limit of f of x as x approaches 2? This is not a trick question.
1.
1.
They are approaching a 1. We would agree from the left they're approaching a 1, from the right it's approaching 1. Now, what is f of 2? f of 2 is 0. because that's where the dot is. So the function value there, okay, is 0, but the limit is 1.
I'm getting this over now, but when I
Oh,
do it,
okay.
I'm Which
Gone.
on the homework, we don't put both of them, we just put the one that it asks.
Yeah, usually the one that you
Okay.
ask, it's asking for. Yeah, homework's actually, easier in some of these. Look at the odd problems, let's scan through them and let's find one that's trickier and one that you're not sure about. Or just, one for fun. Has to be odd. Kirsten, I'll let you choose.
Well, okay.
I'll allow you to pick an even one, I guess.
I have a question.
I don't
Sure.
have.
Does the numbers, does these like being matter? Or is just the X?
Yeah, that's what I was wondering.
of
What
the-
are the numbers for on the side then?
That's just showing you what the function
Oh,
is,
like,
right?
Oh, just
I'm actually giving you the equation, yeah.
Okay.
I should say, I'm actually giving you the graph, lucky ducks.
Oh, but before we like, will we get to a point where we're gonna have to like do this all?
You're always, I'm also gonna probably give you Desmos at any given time, or a graph, yeah, I'm not gonna, no, like, this is literally what Ms. Hassel and I were talking about, you're at the point where like, I want you to analyze what technology is gonna give you, okay?
Yeah.
I'm not going to expect you to do something that a calculator or graphing can do in like a millisecond, okay? What about 14?
Okay, wait.
Isn't that?
I thought we were doing odds.
Yeah, well, fine, okay,
Oh, no,
14's fine, 14's fine though.
okay,
You got it.
so we should be able to get pretty quick at this. What's the limit of the function as x approaches 1 from the left?
From the left,
From the left.
1.
Robert says 1, I need someone else.
Yeah.
From the right, what is it, what are the y values approaching?
Is it
Negative.
-2, right, so what is the limit of f of x as x approaches 1?
Oh, then fine.
We would technically say, yeah, it does not exist. We'll say D and E. Which one of those cases is it?
Oh, that's a difference from the
First.
The behavior differs from left and right. See, look at y'all, super fast.
Oh, yeah, oh.
What about 15?
Oh no.
What are the y values, what is the function approaching, what are the y values approaching as x approaches -1 from the left? Robert says 15, looks like from the left we're approaching -1. Ladies, what about from the right? What are the y values? What is the function approaching from the right? Also -1. So what's the limit of the function as x approaches -1? -1.
So we just put like an
15.
equal and -1?
You just put equals -1 and you're done with 15.
Oh, wow, I feel like this is a trick, like a trick
It
thing.
is.
Like, this seems too easy to be real.
It is. I'm literally asking you, what is the function trending to? What is it getting closer to? Like, I'm not even asking you to like figure out what the y value is. I'm literally saying, trace it. Where are we going? I'm gonna ask you either, where is it going from the left? Or where is it going from the right? Or I'm gonna ask you, what's the combination answer?
And if they don't match up, it's
Negative
a-
one, right?
If they don't actually, I couldn't summarize it better myself, okay? So, this is solving limit problems. Did you kill it, or we're still recording?
Yes.
These are limit problems by graph. Now, it seems super easy in class, but you go home and it's all like, "Ah." Okay, so give every problem, a good solid try, all right? Tomorrow, I'll have a lesson. I think tomorrow's lesson is gonna be, hopefully it'll go pretty quickly. And I'll try to make, there's 10 to 15 minutes at the end to answer any questions. And you'll be like, that's what I thought it was, but I just be sure, right? So spend time tonight. We'll probably grade this, not tomorrow, but the next day. Okay, so we'll probably grade this Thursday. I'll make a note over here on the board. Thursday, 2A.
This is like better.
Thanks for watching. You can kill the people.